This machine is all about transforming straight metal bars into curves, rings, and spirals for countless projects. The MC150B pipe and profile bender brings serious versatility to the shop floor. Setting up for a perfect bend always starts with the right rollers. Each profile or tube shape gets its own roller combination. You can see the team here placing and tightening the roller sets by hand, making sure every adjustment fits the material. It's impressive how a few simple tools can handle such a huge variety of metal shapes and sizes. Once the rollers are in place, the bending begins. Flat bars are first fed between the rollers, and the upper handle is lowered until it meets the metal. The operator alternates the machine's direction, slowly forming a smooth arc, checking the bend after each pass. There's real satisfaction in watching a 6-meter flat bar become a precise, repeatable ring. For edge bending, the opening between rollers is adjusted to match the bar thickness. Square, round, or rectangular bars get their own setup. With each pass, the correction rollers on the sides straighten and refine the curve. You'll notice the process isn't rushed. Careful control keeps the material from distorting or kinking. Even U, T, and angle profiles can be bent with the correct roller combos. For stainless, aluminum, or delicate materials, special Cestaron rollers prevent scratching and contamination. The machine even allows you to tilt it for easier handling of large or high-radius bends, a really clever touch. Every part of this process highlights the blend of craftsmanship and engineering. The MC150B's hardened steel rollers, 40mm shafts, and dual-powered lower rollers deliver plenty of torque, making it possible to bend up to 50mm round tube. Watching this team work, it's clear that attention to detail and the right setup make all the difference. That's how complex shapes are made simple, safe, and consistent. Precision machines in action. Watch innovation shape every detail live here. Steel bending takes center stage with the APK 180 hydraulic profile bending machine. Massive steel beams are loaded and locked in place as hydraulic rollers move into action. The machine's power is obvious. The steel slowly curves under controlled pressure, creating flawless arcs with each pass. Operators monitor every setting, adjusting force and speed to match the exact requirements of the profile, whether it's round, square, or custom. The system uses heavy-duty hydraulic cylinders, applying consistent force that eliminates distortion and delivers perfect, repeatable bends. Watching the steel transform is honestly captivating. Precision sensors and gauges help guarantee accuracy down to the last millimeter. Once the shape is set, parts are removed, checked for evenness, and lined up for the next step or batch. The APK 180 makes tough jobs look almost effortless, and the sound of steel yielding to the rollers is unforgettable. That's true industrial power at work. Molten gold flows for the first time at Detour Lake Mine. 6 years of hard work and teamwork captured in a single, glowing moment. Watching those gold bars cool and shine is unforgettable. Every pour here marks real progress, and you can feel the excitement. Steel profiles take shape under the powerful force of the CY3 RHS 3-roll hydraulic bending machine. The operator feeds thick steel sheets between the rollers, sets the precise bending radius, and hydraulic cylinders apply uniform pressure. The steel curves smoothly, forming perfect arcs or circles as needed. Each pass is monitored closely, with adjustments made in real time to match the exact specification for every project. The machine's strength is clear, but what really impresses is the control. Every bend is repeatable and precise. There's a certain satisfaction in watching raw steel yield and flow into shape, especially when a tough material responds perfectly under pressure. This machine turns heavy, unyielding steel into custom forms that power countless industries. Building a 42-inch, 50-ton ball valve in just 12 weeks takes serious skill. The process moves fast. Assembly, deep welding at 19 centimeters thick, then sandblasting, painting, and gear mounting. Each step is carefully checked and tested. Seeing this massive valve prepped for a gas pipeline, you can't help but admire the teamwork that brings heavy engineering projects to life. The journey of every cable begins with a glowing copper slab, heated until it radiates with intense energy. Scrap copper and slabs are loaded into a powerful furnace, where intense heat turns solid metal into a glowing liquid. You can almost feel the energy radiating off the surface. The liquid copper flows out and is guided into multiple water-cooled molds, each one forming a separate, continuous copper strand. As soon as the hot metal meets the molds, it solidifies into long, thin rods, which are immediately pulled by rollers. Rows of fresh copper wires stretch out in parallel, gliding through precise guides. The wires are cooled and cleaned as they move, their surfaces shining under bright lights. It's incredible how one machine turns molten metal straight into dozens of perfect copper wires in a single pass. Every strand is monitored for diameter and quality before being coiled into massive reels. Watching this streamlined process, you realize just how much control and technology go into every meter of copper wire. Each reel leaving the line carries the promise of reliability and pure engineering. Lost foam casting relies on perfect assembly, and this gluing machine from Wuhan gets it done. Foam patterns are lined up and automatically clamped in place. The adhesive head travels along precise paths, dispensing glue exactly where needed. There's almost an elegance in how each bead joins complex shapes. Once glued, the patterns are pressed and held for a short cure, forming a single, seamless part. Sensors monitor pressure and position, ensuring every bond is strong and gap-free. It's amazing to watch detailed, lightweight foam structures come together so smoothly, ready for the next step in the casting process. This careful gluing stage makes all the difference, setting the foundation for flawless metal parts down the line. Forging at MSV Metal Studenka begins with certified steel, tested and stored under ideal conditions. Raw bars are cut to size by high-speed saws, then heated in gas or induction furnaces until they reach forging temperature. The glowing billets are transferred to massive drop hammers and hydraulic presses, where skilled smiths and precise dies transform them into complex parts for railways, construction, or automotive uses. Each strike shapes the steel with astonishing force, and the control at every step is impressive. Large components can reach up to 100 kilograms. You can feel the intensity in the forge, as every movement demands focus and skill. After forging, parts undergo trimming to remove excess material, then are carefully calibrated and deep machined. This is where CNC technology comes into play. Multi-axis machining centers refine every detail, ensuring dimensions are exact and surfaces are flawless. CNC milling, turning, and drilling processes allow for complex geometries that would be impossible with manual methods alone. Once machining is complete, parts move to heat treatment lines for normalization or tempering, which optimizes mechanical properties. Powerful shot-blasting machines clean surfaces before a thorough inspection for size, shape, and surface integrity. Specialized labs carry out mechanical and metallographic tests. Only components that meet every specification are approved for finishing, painting, or galvanizing, and final packaging. Watching the transition from hot steel to high-precision parts is a real showcase of industrial skill. Few things are as satisfying as watching solid steel turn into something so flexible and essential. Inside this factory, the journey starts with raw steel, melted in towering furnaces until it glows a blinding white. The molten metal is cast into hefty cylindrical billets, thick, round rods that set the stage for everything that follows. Once cooled, these billets are inspected for flaws, then stacked and transported to the next stage. Now comes the real transformation. Each billet is reheated to a glowing orange and carefully lined up at the entrance to a powerful drawing machine. Like dough pressed through a pasta maker, the hot steel billet is forced through a small circular die. Under tons of pressure, the steel flows forward and thins out, emerging as a long, flexible wire. High-speed rollers keep the line moving smoothly, allowing for continuous, uninterrupted production. A high-pressure spray cools the wire instantly, stripping away surface oxides and revealing its smooth finish. Operators check the diameter and straightness, guiding the wire through rollers before it's wound into huge coils. Every step is monitored for quality. Nothing leaves this factory without passing inspection. There's a real sense of skill and teamwork in every part of the line. Watching solid billets transform into slender wire, you realize just how much engineering and effort it takes to make something that seems so simple. Turning massive shafts with CNC precision, each cut feels powerful, every detail perfectly engineered. Coke is the key fuel that makes steel production possible. At OKK Koksovny, making coke starts with mixing and grinding coal blends, then storing them in silos under careful supervision. The prepared batch is compacted and pushed into giant oven chambers, heated without air, to nearly 1,100 degrees Celsius. After hours inside, the coal transforms into solid coke, a hard, carbon-rich fuel perfect for the intense heat needed in blast furnaces. Watching red-hot coke pushed out and cooled with water vapor is always a thrill. Coke is the key fuel that makes steel production possible. At OKK Koksovny, making coke starts with mixing and grinding coal blends, then storing them in silos under careful supervision. The prepared batch is compacted and pushed into giant oven chambers, heated without air, to nearly 1,100 degrees Celsius. After hours inside, the coal transforms into solid coke, a hard, carbon-rich fuel perfect for the intense heat needed in blast furnaces. Watching red-hot coke pushed out and cooled with water vapor is always a thrill. If you've ever wondered how those razor-sharp carbide teeth are attached to a TCT saw blade, this is where the magic happens. The YUANDAZDH 800 automatic brazing machine is engineered for circular TCT saw blades from 120mm to 800mm in diameter, with a brazing capacity of 6 to 12 teeth per minute. The process begins with the vibration turntable, which automatically screens and feeds carbide tips. Optical fiber sensors perform first and second detections, ensuring each carbide is correctly positioned. The transfer clamp delivers the leveled carbide to the blade, while the system dispenses solder paste and applies solder tape in precise order. The machine offers 3 working modes: solder tape, solder wire, or a combination of both for increased strength. Solder paste is dispensed first, followed by solder tape application and a second solder paste application. The slitter mechanism automatically cuts the solder tape, and a mechanical limit keeps each solder position consistent. High-frequency induction heating rapidly melts the solder, bonding the carbide tip to the steel blade. A water chiller cools the heating system, activating automatically if the temperature exceeds the set threshold. Real-time temperature is displayed on the HMI touchscreen, where hundreds of parameters can be adjusted for each job. After brazing, the machine independently tempers each tooth for increased durability. Fault prompts, repair functions, and manual heating options enhance operation and safety. Additional features include stainless steel protective covers, programmable controllers, and digital fiber sensors. Throughout, the EN ISO 13849-1 dual-check safety system monitors every step. The result is a TCT saw blade with evenly brazed carbide teeth, ready for demanding cutting tasks. The birth of a traditional bronze bell is a journey filled with patience, artistry, and a touch of suspense. Here, the process begins with drawing a precise profile of the bell, transferred onto a wooden pattern. This curve is no accident. It defines the tone and resonance that the finished bell will produce. A core, made from a carefully shaped mix of clay and sand, forms the inner mold. Over this, artisans build a mock-up called the false bell, which becomes the canvas for intricate decorations, friezes, and inscriptions. Every detail, whether a parish name or a religious motif, is first crafted in wax, then pressed into the clay. More clay layers are applied, sealing these features in a thick shell called the jacket. Once dry, the false bell is removed, leaving a perfect negative ready for casting. The mold is buried in earth, its walls compacted for insulation, slowing the cooling so the bronze, an alloy of 78% copper and 22% tin, sets with a fine, musical grain. Watching molten bronze flow into the ground never gets old. It's pure anticipation. After cooling, the mold is unearthed, and months of work are revealed. That first strike of the clapper is the real test. Every heartbeat of effort rings out for all to hear.